Hey everybody, this is Larry. This is day 11 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. No extra points. Let me know you have one. What is today's poem? Find median from data stream. This is a hard. I've solved this before. Now that I notice this, I cannot notice this, but this is a moving median. It seems like, right? So add number and then find median. So yeah, this is a moving median, and this is a very well-known problem. It's just basically keeping track of two lists, right? We have one heap on the left, one heap on the right, and then and you basically try to keep them both the same size, and maybe determine your invariance that you want to hold, so that the invariant that you want to hold true at the end of every operation, so then you can kind of build off those assumptions. That's basically the idea. I think after that, hopefully the description is okay, because basically what you want to do is keep track the last or the middle number, right? And the middle number, if you have two heaps that are roughly the same size, then that's going to go. We'll talk about the math about the complexity at some point, but this is a kind of a well-known problem, to be honest. So yeah, and there's also a variation where you find the median of the last k numbers, for example, right? So there's stuff like that that you could play around with as well. But those are just kind of like bonus questions or something. The follow-up is 1 to 100. Well, you can then maybe even do binary search or something, right? Or you do a prefix sum or binary search on the prefix sum, or you do what's it called, segment tree, if you like. Here you can also just like do the same thing, but with outliners outside from the left or the right, and then do your math there. I don't know if it's interesting to go over, but the real constraint is just these things. So yeah, and in a general case, that's what you want to do. You basically want to have a left heap and a right heap, and on the left side we want to the top of the heap, we want the max number, because the smaller numbers don't matter. You just want the max number from the smaller heap. So this is going to be a max heap, and this is going to be a min heap, right? From the right side, because for all the bigger numbers, you want the smallest number, because that's the only number that matters in terms of a median, right? Because a median, you only care about at most two numbers. One is when the total number of items is n, then if the total number of items is n, if n, which is the total number of items, is odd, then you only care about one number, and if n is even, then you care about two numbers, right? The two middle ones and an average. I think that's what they tell you anyway. I mean, yeah. So let's kind of figure that out, and maybe the invariant that I would establish is that self.left might has either n over 2 or n over 2 plus 1 items, right? Or something like this. So that basically what I'm saying is that the extra item will be on the left side. You don't have to do it this way, but for me, just defining it means that now we don't have to worry about, having this invariant means that every function that we implement, we don't have to check whether the invariant is true. Every function is responsible for it. In this particular case, there's only two functions, it seems like, so it's not a big deal, but it is a good habit to get into defining your invariants at the end of every function, every method, and so forth. So okay, so then now here, as we said, so there are a couple of ways you can write this, but the way that I max heap, I mean, by default, I think for this one I'm going to be a little bit lazy. Oops. I did say it was going to be a max heap, but I'm going to use another data structure to represent the max list, max heap, and that's going to be sorted list. I find that, at least in Python, a little bit easier to read for max heap, because it's not ambiguous. It's not as ambiguous, though obviously the implementation is, has a different complexity profile, but if you're just talking about an abstract data type where most functions will be O of log n, if it wasn't a heap, that's fine. But we're able to kind of define it way clearly. So here we go, s dot left dot add num, right? And then here, maybe that's not what we want. Well, actually, maybe I changed my mind. I think the way that I want to do it is that s dot right has the extra item if it's odd. Because then now I can do this. I mean, you could do it either way. It doesn't really matter. But if self dot left, if length of self dot left is greater than length of self dot right, then usually this can only be off by 1. Then we pop off the biggest number. So v is equal to this. Self dot left dot remove v. And there might even be a pop. Let me check this for a second. I actually don't know if this is true. We move the okay, so we move and return. Okay, that's fine at the index. So yeah, so I could do something like and then self dot right dot add v, right? So then now after this, so here this can only happen when left plus 1 is greater than right. After this, right plus 1 is equal to left or something like this, right? Yeah, or it's gonna be left plus 1 is equal to right, something like that. I don't know, maybe that's wrong, or at least the way I phrase it maybe is wrong. But here, okay, right? Is that fine? Yeah, and then now, we don't return anything. Is this enough? No, because the other case is if they're equal and you add a number to the left, then, or like if the, for example, yeah, so we do actually have to handle the other case as well. For example, if you have like 1, 2, 3, 4, and then the right side you have I don't know, 10, 11, 12, 13, 14. So the right is one more item, and then you add like a 20. You still have to do something, right? You basically have to go, yeah. So in this case, if self dot left, the biggest number on the left is greater than, I guess, the smallest number on the right, that's the only thing you need. And of course, keeping track that self of right is greater than 0. Self dot left always has greater than 0 because of this. Yeah, then v is equal to the self dot left pop -1. I guess we can do it another way. Maybe this is too confusing. Yeah, maybe this can be, I don't know, which way is a little bit better? Whatever, we could do this way. V is equal to pop -1, and then again self dot right add v. But then now, in this case, we pop this, we put 20 in here. We know that the so we have to get it back from the other one. So yeah, self dot right dot pop of 0, self dot left dot add v. I think that's mostly okay, hopefully. And then now the median, which is that if length of self dot, and here, if you want to assert these things, I'm going to add this here, so that if it's not true, then it's going to be not true along the way anyway. But yeah, if it's always going to be smaller than you go to the 1, right? You could even be more precise, maybe like the absolute amount of them is great or something like that. But I'm just going to start with this and also assert here, just as an easier thing to debug later. Okay, so the length of the left plus length of self dot right mod 2 is equal to 0, meaning that if this is even, what happens if it is even? Oops. Then we just take the I guess the only case where this is not true is if it has 0 elements, but I don't know that. I'm just trying to see whether, okay, yeah, whether they guarantee for us or we have to do some weird returns -1 or something weird, which happens, right? Yeah, so the biggest element plus the smallest element, and then we just divide by 2, right? And this is a float division. Otherwise, we know that length of self dot right, we know that it's going to be on this, so it's just this. Of course, you could also do another assert, but in this case, length of self dot length plus 1 is equal to length of self dot right, just by definition. And then we could play around. Let's give it a spin. Okay, that looks good for this case. It might not be correct, but I'm just lazy, so I'll let the system testing let me know if I got something wrong. So yeah, looks like I got something right this time. 950 day streak. I should have checked whether the video was on. Okay, thankfully for me it's on, though too late anyway. But yeah, so let's go over the complexity really quick. Here, I mean, this should be, actually I don't know if min or max is O of 1 or O of log n. But either way, let's just say it's log n, because I'm not quite sure. You can optimize it for one or the other. Like if you have something specific, you could optimize, but you know, that's not that interesting for me for now. And here, as you can see, each pop and add is going to be log n, and this add is also log n. So everything's going to be log n, right? Because we just do a constant number of log n operations. So this is log n, this is log n, and Larry is log n happy, I guess. That doesn't mean anything. I was trying to come up with a pun, kind of failed there. Anyway, that's all I have for this one. Let me know what you think. This is a hard problem, so I'm going to call it a night. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.